Hello viewers, today we learn about water. Of course, water is known to all of us, but there are few things that we do not know, and especially when water has to be used for laundering purpose. And so, in this episode, we will learn about the water hardness and its types, and also we will see how this hardness can be softened and so that the water can be used without any problem, and also we learn about the role of sequestering and also chelating agents in softening of water. Water is an important element in laundering process, as it is an excellent solvent to remove the dirt from the clothes. If the water is very clean and free from solids, then that makes the laundering easier for all of us, and we will be able to remove the dirt very easily and also use the soap very effectively. But if it is not so, then definitely it poses problems. When we take the water, water is available everywhere, and especially in cities and towns, we find that this water is being treated and then it is supplied to the households. And whereas in villages and all, you find that the water is not treated, and so there will be a problem even for laundering of the clothes. There are three sources mainly from where water can be taken. The first one is the rainwater. You know that everything comes from the rain, and that water is supposed to be the very pure and also soft. But when it comes through the atmosphere, it sometimes pick up some of the impurities, and like dust will be there, and maybe soot, and also suspended particles in the air, and gases something like carbon dioxide, nitrogen, ammonia, oxygen, and things like that. It will take all these things and then it will fall on the soil. And so, when we collect this material, it is going to be pure and soft, but maybe few solids are there, that is not a problem at all. But second source, it will be the surface water. That means for any surface water, rain is the original one, and when it falls on the soil, it actually flows, and then it flows into the oceans or rivers or lakes or ponds or tanks and all. And so, this surface water, if you take, this is we should say that it is contaminated, because it flows from one place to another place, and impurities from the human and animal sources will be there, and also any salts that are there in the soil will also be taken through that. And so, it is the most contaminated water source, and unless it is treated, we cannot use it for the human consumption especially, and even for laundering purposes also, maybe it requires some treatment. And the third source is the groundwater, and rain that falls in the soil, it is percolated into the ground, and that forms the groundwater. And this is supposed to be a better water when compared to the surface water, because it does not contain that kind of impurities that you find in this. And but here what happens is, as it percolates through the beds or layers of the soil into the wells and all, and we find that the particular soil, if it contains some salts, the salts will get dissolved into the water, and so it may become little hard, but this is the main source for many people, and for supply of small communities and all, and even in the households, we find that groundwater will be the main source for all these things. So, it may contain some of the salts which are not required and which are going to interfere with our laundering, and which we will see how we can remove these things. Hardness of water. Water is described as hard when we treat it with the soap, and if it does not give particular lather, and but it forms an insoluble scum on the surface. But if it is a soft water, definitely it gives very good lather, but if the scum is formed, definitely it is going to be a hard water. And this hardness is due to some salts that are dissolved into water. So, unless these are removed, and there is going to be hard process in order to launder the fabrics. The content of calcium and magnesium in water causes actually the hardness, and if it is more, then it is going to be more harder, and if it is less, it is going to be less harder. But these things have to be removed before it is used for the laundering purpose. Usually, the hardness of water is expressed in four ways. One is the parts per million, that is called as ppm, or milligrams per liter or degree French or degree Clark. So, the relation between these 4 expressions are or units are, 1 ppm is equal to 1 mg per liter, that is equal to 0.1 degree French, and that is equal to 0.07 degree Clark. So, whenever we express it maybe in ppm, it can be expressed in milligram per liter, or it is in degree French or degree Clark and all. We can actually calculate and see how much hardness is present. If the level of calcium and magnesium is more than, that is salts, it is in the form of a salt. If it is more than 60 ppm, definitely we call it as a hard water. Maybe it is moderately hard, but below 60 ppm generally it is softer for our laundry purpose. Maybe for drinking water and all it may require less than that, but for our laundry we say that yes, 60 up to 60 ppm it is okay, but from 60 to 120 ppm it is moderately hard, and more than 180 ppm it is generally very hard. This hard water has to be treated in order to be used for laundry purpose. And now we will see what causes actually this hardness. This hardness we can explain it in 2 ways, that is temporary hardness or permanent hardness. So, when bicarbonates of calcium and magnesium are present in dissolved condition in water, that causes temporary hardness, which can easily be removed by just boiling, or there are maybe few methods are there and which we can use it, but just boiling the water disintegrates into kind of a calcium carbonate, and which precipitates, and the carbon dioxide is removed, and thus we will have the hardness being removed and the water becomes softer. Even with the magnesium bicarbonate it becomes the same. When coming to the next type of hardness, that is permanent hardness, and that is caused by the chlorides and sulfates of calcium and magnesium. So, these two are not easily removable, but so we have to adopt a kind of ion exchange methods in which the calcium and magnesium ions are exchanged with soluble ions in water, so that the water becomes softer for use. So, temporary hardness is caused by the bicarbonates of calcium and magnesium, and whereas the chlorides and sulfates of calcium and magnesium make it permanently hard. Softening of water. The process of removing the hardness in water is called softening. It is actually exchange of calcium and magnesium ions in water with sodium, so that this will not form any scum when it is treated with soap. Actually, the positively charged anions that are present here in water, this forms a bridge between dirt and also the fabric functional groups of the textiles, and thus it will not allow for the proper action of the soap. And so, these ions if they are exchanged with the sodium, the compound which is formed with sodium is water soluble, and so the scum is not formed by this one, and thus softening takes place. This is the main principle of softening of the water, either with the use of a boiling or anything else. It is exchange of the ions of calcium and magnesium with sodium, so that sodium is soluble in water and it does not form any scum with the soap. That is the main thing. And then coming to the softening of water, temporary hardness, and there are two methods. One is the boiling. That is a simple boiling method in which the water is boiled and then it is decomposed into calcium and magnesium carbonate, and which precipitates and then leaving carbon dioxide as a gas and water. And so, this can be washed and removed, that can be filtered and removed, and so boiling will be the simple method of removing the hardness of water. And maybe another thing, that you can even add soda or you can add borax into it, and even ammonia and all the even soap. These are all the things that can remove the temporary hardness, But when we take the economy into consideration, borax is also costly, and even soap, of course, when soap is used as a softener, then it is a waste, because it loses the cleansing power of that, and it is only used for the softening of water, and so we have to use excess soap in order to make it softer. In the same way, soda can also be used. Soda is also a cheaper method, but what happens is, and there is a danger with the soda, because if it is an excess amount, if it is present, then it causes a problem and it interferes with the laundering process. And so, the best method is to boil the material and remove the hardness. So, the second method of removing the temporary hardness is Clark method. This is done on a commercial scale, wherein the lime, that is calcium hydroxide, is used to decompose the water and remove the hardness here. And this limestone or lime, it can make the calcium carbonate to precipitate, and also it will release the carbon dioxide and then water, and calcium carbonate, which has come in the form of a precipitate, can be removed by just washing in water. That water becomes softer by this method. The permanent hardness of water is removed by more sophisticated processes that are in vogue today. One is the permitted method, and it is a modern method of removing the hardness, and it utilizes a chemical called permitted, and also it can also be called as a zeolite. When you take the chemical name of this particular zeolite, it is a hydrated sodium aluminum silicate, and so it is capable of exchanging ions reversibly. This particular chemical is present in a big tank, and usually it is placed over a sand layer, a little coarse sand layer. It is present, and the water is made to pass through the particular bed, and it goes to the bottom, and then from the bottom it rises to the top. And then if it is a temporary hardness that is present, and this will work with the temporary calcium bicarbonate or magnesium bicarbonate, and it will exchange the ions, take up the calcium and magnesium, and it forms Na2P or Na2Z. This permitted is packed loosely in a bigger tank over a coarser sand layer, and water which has to be softened is sent into the bottom, and from the bottom the layers of water raise and come onto the top. And while coming onto the top, the permitted which is present is capable of removing the temporary hardness and also the permanent hardness of the water by exchanging the calcium and magnesium ions with sodium ion. And so, this permitted will become by taking those ions as a calcium permitted or magnesium permitted, and thus it will be able to remove these things. And if it is a temporary hardness, the calcium bicarbonate is acted upon by the sodium permitted, and it becomes calcium permitted, and also it becomes sodium hydrocarbonate, and then which can be easily removed, and there is no problem. In the same way, magnesium bicarbonate is acted upon by the permitted, that is Na2P, and it becomes magnesium permitted, and then sodium hydrocarbonate, and thus the temporary hardness will be removed from the water, and it becomes totally softened. And in case if it has a permanent hardness is present, calcium chloride, because it is done by calcium chloride or magnesium chloride. So, that is treated with sodium permitted, then it forms calcium permitted and leaving sodium chloride, that is salt. And if it is magnesium chloride, again in the same way, sodium permitted will take up the magnesium and form the magnesium permitted, and then sodium chloride will come out in the that can be washed off. And in case of sulfates of calcium, that sulfate of calcium, when it is acted upon by the sodium permitted, it becomes a calcium permitted, but it comes out in the form of a sodium sulfate. So, this sodium sulphate which precipitates can be removed. In the same way, it forms with the magnesium sulphate. Magnesium sulphate, when it is acted by the sodium permeate, and it gives magnesium permeate and it leaves sodium sulphate, and so that can also be removed. And thus, the sulphates and the chlorides of both calcium and magnesium will be removed, and the permeate is taken that particular thing, and then it makes the water softened. And so, the water that is coming up on the surface through the layers of the permeate, when it comes up, it is totally safe and it is totally out of all these salts which cause the problem with the soap. And so, the water taken from here, and when it is washed with the soap, and it gives readily lather, and there is no scum that is formed, and it is not going to interfere with the fabrics. Otherwise, it is a very big problem in case of laundering. When sodium permeate is converted into calcium and magnesium permeate, and it can no longer soften the water. In that case, what happens is they send one brine solution into it, that is 10% of sodium chloride solution, which is capable of removing the calcium and magnesium ions from the permeate, and thus it regenerates into sodium permeate again, and these things can be washed, and then the whole permeate can be regenerated, and it is ready for softening the water again. The second method is ion exchange method, which is the most modern method that is being used for softening of the water. And here, all the solids and all other things that present in the water are being removed, and the water becomes totally softened. It can be used for anything, and it can be something like a distilled water. And here two types of resins are present in this. One is a cation exchange resin, and another one is anion exchange resin. Cation exchange resin contains carboxyl groups and sulfonic groups, and these functional groups are capable of exchanging their hydrogen ions with cations. While anions exchange resin contains amino group and also hydroxy groups, and these are capable of exchanging hydroxy group ions with anions. In this process, two columns are present. In one column, it consists of cation exchange resin, and in another column, it contains anion exchange resin. The hot water is first allowed to pass through a column containing cation exchange resin, which removes all the cation like calcium and magnesium ions, and release hydrogen ions. So, the reaction that takes place in the first column is that the resin with H2 acts upon the calcium chloride, and it forms calcium resin and HCl, and in the same way the magnesium chloride, it is acted upon resin, and it forms HCl again here also. And but in case of calcium sulphate, and we find that sulfuric groups are being produced. The anions like chlorides and sulphates are converted into acid like hydrochloric acid or sulfuric acid, and which is passed through another column containing anion exchanger. That is, this resin contains OH groups, and where a reaction takes place in such a way that the resin containing OH is acted upon by the acid which is taken from the first column now, and this is HCl, and then it becomes resin with chloride, and then water comes out of it. And in the same way, you find that when it is acted upon by the H2SO4 which is present, which is taken from the first column, and the resin takes up the sulphate, and then water comes out from it, and thus the water is obtained free from all cations and anions, and is called soft water or distilled water. The regenerated acidic and basic resins are again reused for softening of hard water, and the cations present in hard water are exchanged for sodium ions. Therefore, this method is also called as ion exchange method. Use of sequestering and chelating agents in softening water. Chillants according to ASTM A380, these are the chemicals that form soluble complex molecules with certain metal ions, inactivating the ions so that they cannot normally react with other elements or ions to produce precipitants or scales. A sequestering or a chelating agent is a complex forming auxiliary with metals such as iron, copper, nickel, zinc and magnesium that are present in water and affects the textile processing. So, sequestering agents form coordinate bonds with metal ions to form a complex. And so, the sequestering agents used for water softening form water soluble complex salts with calcium and magnesium ions in the water without producing a precipitate. The calcium and magnesium ions are held strongly in the complex so that they cannot replace sodium of the soap or any other washing agent, and thus the water is totally softened. Some of the sequestering agents used for water softening also possess cleansing power. Therefore, these water softeners enhance the the detergency or the cleansing power of the soap, and thus these can be used as a surfactant and also textile surfaces. These agents are also capable of dispersing and suspending the dirt, that is also action of the soap, and so these having the detergency power, and thus these can be of much use when they are used along with the soap. And some of these sequestering agents are polyphosphates such as sodium tripolyphosphates, sodium hexametaphosphate, sodium pyrophosphates, sodium polyphosphates in alkaline medium, and sodium salts of ethylene diamine tetraacetic acid, sodium salts of nitrile triacetic acid or citric acid. And when hard water is used in our homes in boiler, and it causes a lot of problems. One is that the scale or sludge formations, you find that they are formed in the layers, and which is difficult to remove, and then priming and foaming of the water just because of these things present in the boilers, and also caustic embrittlement, and you find this kind of corrosion, and all these are the problems associated with the hard water in boilers. And so, it is always better whenever we use this water for laundering to remove that particular thing first and then only use it, so that we will be able to maintain all the laundry equipment in a proper way. So, thus water which is to be used for the laundry purpose has to be softened, so that we will not have any problems, because when we use soap along with water, when hardness is there and we are losing some soap, and because which is a costly affair today, and when the soft water is used, and we will be able to do the laundering in a much better way. When hardness is there and we find the fabrics becoming yellower and also becoming dirtier, and that's we do not know why it is happening. But when these things happen, when you use some soda or when we boil water and use it, these things can be removed. And so, knowing about the hardness of the water that we are using is always better, so that we can use the amount of soda that should be used in order to remove that particular hardness. And so, when hardness is removed and the laundry becomes much easier and much happiness, with much happiness we will be able to do the laundering. And so, water has to be softened and it should be known to everybody.